Hey everyone, here's a review of the math problem sets. Over here you see 14,000 millimeters, and we want to figure out how many meters that is. So this is one of those basic problems. We need to understand that there's 1,000 millimeters in 1 meter. So one way to look at this would be to uh, know that you have 14,000 millimeters, and then this is going to be multiplied by 1 meter divided by 1,000 millimeters. Another way to put that visually is I'm going to insert a quick chart or a table. So this is that method you can use. Hold on, get rid of this. Okay, so you have 14,000 millimeters, and we're going to multiply that by 1 meter divided by 1,000 millimeters. So why can we do this? The reason is because this essentially is 1, right? We know that 1 meter is 1,000 millimeters. So when you multiply anything by 1, it's going to be the same number. So we're not changing this number, but we are going to convert this. So now we can actually cancel these units, and we know that our units at the end now will be equal to 14,000 divided by 1,000, and so it's going to be 14 meters. So remember, you have to show your work here. You can't skip over that. If you don't show your work, you're not going to get the full credit. So same concept can go over here. 1 liter is 1,000 milliliters. So this number is actually going to be quite large, right? 1 kilometer is 1,000 meters. So this number is actually, one way to do this is to move that decimal place over 1, 2, 3. So this is actually going to be 78 meters, right? But you still need to show your work by actually drawing that out or explaining it briefly. On the exams, you can actually explain how you did it. You don't necessarily have to show it mathematically. You can also explain it in words. Over here, we have scientific notation. In scientific notation, we want to make this number between 0 and 10, so 2.5, and I move the decimal over 1, 2, 3, 4 times. So this would be times 10 to the negative fourth. This is going to be the opposite, right? So this is going to be 1.15, because that number is between 0 and 10, but I'm going to move this over 1, 2, 3, 4, 5 times, just the other way. So this is me times 10 to the fifth. When you are adding, this is adding scientific notations that have the same exponent and base. They actually can be treated like variables. So 2.96 plus 2.96 plus 1 actually equals 3.96 times 10 to the 7. You see how this is being treated just like a variable, even though these numbers are quite larger? Over here, we have division. So when you're dividing exponents, you actually are going to be subtracting them. So let's just start with our constants. So 6 divided by 3, we know the answer 6 divided by 3 is 2.0 times 10 to the, okay, so 6 minus negative 4. So when you're subtracting a negative, you're actually adding. So 6 plus 4 is 10. So this is our answer here. When you're multiplying, you're actually going to add these. So this is 2 times 3 is 6 times 10 to the 15. Okay, let's take a look at the other one over here. So this one is going to be a little different. I actually added this on as an example, but yours looks like this. What is 45% of 1800? One way is to know that 45% is actually a proportion. So if you're doing that 45, it's actually divided by 100, right? So that is the proportion. And then this is what you want to multiply it by 1800. And so there's a couple ways to do this. You're going to have a calculator, so it's not going to be very hard. You can solve that, but you still need to show your work. If this said something like miles, you need to be including that throughout your work. So over here you have miles, and in your answer you have miles. This gas engine is 6% efficient, which by the way is horrible. But we know that 6% is 0.06. A lot of people mess up. That's another way of doing this, right? Because in the one above this, we did 6 divided by 100. But that's really the same thing as just moving that decimal over twice and understanding that 6% is also the proportion that is 0.06. So you're going to multiply that by 21 gallons. Notice I'm writing gallons. Yes, you need to include units in your work. This is going to equal, oh gosh, Mr. Harkins needs a calculator. 0.06 times 21, because I don't have my answer key. So 1.26 gallons. So this is what is used. That is not what this is asking. This is saying what is wasted. So you're going to have to then do 21 gallons minus 1.26 gallons. Do this in my head. That is 19.74 gallons wasted. You can actually approach this the other way if you want, because you have to do multiplication and have to do subtraction. But what if you do it the opposite way? You could have done 100% minus 6%, right? Because we know that 6% is what's used. So what is wasted? So that's going to be 94% wasted. And then we can do that 0.94 times 21. And that actually is going to equal to our 19.74. Okay, Greenland ice sheet has 2,850,000 cubic kilometers. So that's a lot. And this is a, it's melting at a rate of 0.006% per year. How many cubic kilometers are lost per year? So again, it's pretty simple math. You need to put your numbers here. 2,850,000 cubic kilometers. That's a three-dimensional measurement, and you're multiplying it by this 0.006 divided by 100. Or if you don't like that, you could just move this decimal over. 0.00006. So make sure you keep track of your decimals here, because that can get kind of tricky. And then it's going to tell you how much cubic kilometers are lost per year, because that's the rate it's melting at. So let's take a look. We have 2850000 times 0.00006, and so it's losing 171 cubic kilometers per year. You have to include this per year, right? You could even, if you want to make sure, you can include this in your answer as well. So you want to include as much as you can in your answers. This last one is using the same logic. So what we're applying here is this, using the understanding of proportion and percents to solve environmental solutions, solve environmental mathematical problems. Okay, this is me signing off. Hopefully that was helpful.